Hello and welcome to my talk, Predict Who Lives or Dies on the Titanic Without a Single Line of Code. But first, let me introduce myself. So I'm Lawrence Lehmann. I'm a computer scientist by training. I'm currently the CTO at Healthcare Systems GmbH. But previously, I was responsible for a big data and AI pipeline at Viva Systems. And I'm personally very interested in machine learning, data science, and artificial intelligence. So this project here is more a private project of mine that I want to show you. So what I'm gonna be talking here about is taking part in a Kaggle competition. So Kaggle is a platform that holds competitions in the data science, machine learning, or deep learning area. And they have the nice beginner machine learning competition where the goal is to create a machine learning model that predicts which passengers survived the Titanic shipwreck. And they provide two data sets. So they provide label training data and test data that we need to run the model on and then later submit. And for this talk, I will be following the data science lifecycle. And in general, it starts first by defining the business problem. We already have it defined here. We want to win or at least score very high in the Kaggle competition. Then the next step is to collect the data. Then we will explore and prepare the data. We will build the model, evaluate the model, and then deploy the model. And in the context of this competition, it means uploading the final results to the Kaggle website. So, business problem defined. We want to win or score very high in the competition. So next step is collecting the data. And usually that's quite complicated, but here, luckily, we also get CSV data from Kaggle. So we get a nicely formatted CSV file. We have the first variable survival column with a 0 for somebody who died and the 1 for somebody who survived. And then further information that we can put into our model. So for the next steps, we will be using NIME. NIME is a free open source no-code data science platform. And that's also where the without a single line of code part of this talk comes into. So in NIME, we have nodes, which are building blocks that can be like here a decision tree learner, which can be a like machine learning model, or it can be some other analytics blocks. And basically with NIME, you can really crunch data, do some data analytics, machine learning, just by dragging and dropping nodes on a canvas and then connecting them in the proper way. There are also some other alternatives out there like Alteryx or RapidMiner. But I think NIME is very easy to use. So let's jump right into NIME now. So this is NIME. I already prepared some workflows here so we can quickly look at them. We already defined the business problem. We want to score very high in the competition. We collected the data, or downloaded the data set from Kaggle. And now we want to explore and prepare the data. So here we see a NIME workflow. First node is a CSV reader that loads the CSV file. And we can see it basically looks like we saw it before in the PowerPoint. We here have like a survived column with the 0 and 1, and then the other data to train the model on. And then something that I did is I took the rule engine node, which takes the survived flag, like a 0 or 1, and just maps it to text. And I just did that to make it easier to read everything. So you can see if we look at the output of this node, we have the same information as before, but a new column added with the died and survived flag. All right, so the next step is looking for correlations. So we want to see which values really correlate with some other values. For this, we use pivot tables. So again, we have a NIME node. we group by the gender, we pivot by the survival, and then we just take a simple count. And if we look at the data, at the output of this node, we can see that female passengers were much more likely to survive than male passengers. And this for us is already like very important information, and we can see that this is of course a value that has to go into the machine learning model so that the model can learn based on this correlation how the survival rates are. We then also should look at some other values. Something that's interesting is the ticket price, so how much somebody paid, as we assume that people with a higher ticket price were more likely to survive. But if we now run a pivot table, we can see that we don't see much. So there's like a lot of different fares. Aggregations don't really work in the pivot table. It's just so many values, and we don't really understand if fare makes sense to use it in the model. So what we now do is we use an auto binner, and that's one of the many nodes that you have in NIME. And what it does is it takes the fare and then puts it into 5 different bins. And bins is basically just groups. So it automatically creates groups and then distributes the fare into these groups. And once we take the output of there, pivot it again, then we see that that we have some correlation here. So the people with the low fare, there the survival rate is much lower than the number of people who died. But if we look at the insane high amount of money somebody paid, they all survived. And then with higher amount of money, there's also like a higher survival rate. So with this grouping, we can see that fare is also something, or the ticket price is also something that should go into the model and that the model should learn from. And here it really makes sense to spend quite a lot of time to look at other values like age, passenger class, and so on. But as the time is quite limited here, I already skipped to the next step, which is preparing the data. And the first thing I did here is build a column filter. Let's look at the output. And it takes out all the things that I do not want to consider in my model. And we can see we have the survival, of course, to where the model learns from, and then some other value. What we can already see here are these question marks. So these are missing values. So one important part in preparing the data is to replace the missing values. For the age, for example, I took a very simple and not so sophisticated approach. I just calculated the median age. And then if the age was missing, again, I took a rule engine. And so if it's not missing, I don't change anything. And if it's missing, I replace it with the median. So that's not very sophisticated, but already helps to fill the values. And then other preparation steps are also replacing missing values on the embarked value, mapping the age to the age bands that we saw before, and the fare to the fare bands. And then again, dropping the calculated columns. So then we can look at the input for the model. So we have survival, passenger class, gender, embarked, age band, and fare band. And if we quickly skim through, we see like all missing values have been replaced. So now let's move to the next step as we have the data prepared, which is building and then evaluating the model. And if we jump right into here, we start with the familiar node, the CSV reader, again, loading the training data. And then here I put a meta node, which just takes all the steps that we did before to prepare the data. All right, again, we change the survival indicator to replace it with the string. And then what we do is, as we want to evaluate the data later, it's important that the model doesn't know all the outcomes. So for the test data, which we can already see below here, the model will need to run on some data that it never saw. So also for the validation, we need to split it into training and validation data. I choose an 80-20 split here. And then I take 80% of the data to train the model on. And here I chose a decision tree, which is not the best model for machine learning, but one that's very easy to understand. And that's also a standard NIME node. And here you can see I trained it on the survival class. There are some other meta parameters that you can set, but I left everything at the default. I trained the model, and then the nice thing about the decision tree is like there's a node to generate a picture from a decision tree, so we can look what the model actually learned. And if we scroll to the root, to the top of the decision tree, we can see that just from the raw data, everything going in, there is a 62 chance of dying and 82% of survival. But then, as we also saw that the gender is very important, the machine learning model also learned that just by looking at the training data, is that the gender is very important. So basically, it created a new branch, a new leaf for female passengers, and there the survival rate is much higher. And then it takes all the other values that we put in. So for example, the passenger class, if the passenger class is low, then we can see that even for female passengers, the chance of survival goes down. So even here, there's a 47% chance to die. And then the model looks at the embarkment, so where somebody joined. So basically now here in this decision tree learner, we have the decision tree as an output. So we put it into a predictor for the validation. We run it on the validation data, and then we can see that we now have a prediction here, which is died or survived. And here we can also see what went into the model. And then to see how good our model is, we can group the results. So we see for 100 people, they actually died, and the prediction is also that they would die. But we can see that the model is not perfect. So there are 7 people who died where the model predicted that they survived. But if we sum up the numbers, we see that we have 82% accuracy, which for this purpose is good enough. So next we load the test data again with the CSV reader, run the same preparation steps, also run the decision tree on it. We need to drop some columns, prepare the data, and then we get the output, which is the ID that we got from the input, and our prediction if they survived or not. So now, as a final step, usually would be deploying the model, but here we, instead of deploying it, we submitted it to the Kaggle competition, and then basically our submission counts, and we see how well we are in comparison to the other competitors. And actually, with this very simple model, the rank that I got when I executed it was already number 4,500, which is not that high, but out of 17,000, that was already surprisingly good, I have to say. All right, so we downloaded the data, we analyzed it with NIME, we prepared it, built the model, evaluated the model, and uploaded the data to the Kaggle competition. You can see here a screenshot from my leaderboard and my rank at the time when I submitted the data. But you can also download the entire workflow that I just showed you from GitHub. I put it into my space so you can download it. There's still quite a lot of improvements to do. So you can download NIME. As I said, it's free. Sign up for Kaggle, download the workflow, and then just start playing with it. See where you can rank on the leaderboard, and see how much you can improve the model. So there's still a lot of room for improvement. And if you want to reach out to me, you can do this via LinkedIn or email. And I'm always happy to discuss questions around this topic. Are there any immediate questions now for this talk?